What caused an air force that was in many ways vastly superior to the Allies to come crashing down? Is there a distinct turning point that made Germany's aerial arsenal impotent against the combined strength of Britain, America, and the Soviet Union? For the first time ever, put yourself right in the middle of the debate as we try to solve the greatest arguments in the history of aviation. What caused the Luftwaffe to fail? In 1933, Adolf Hitler becomes Chancellor of Germany and later the Führer, enacting complete control over the fatherland. Eager to reclaim the lost territories taken from Germany after the Treaty of Versailles, the Nazi war machine realizes early on that the formation of a strong air force is vital. In 1935, it becomes official on paper, and the Luftwaffe is born. The man put in charge of this department is Hermann Göring, a prominent ace from the Great War.
Goering was a World War I fighter pilot. He was not interested in technology. He said something at one point, he said, well, this device is a box with coils, and I don't like boxes with coils. He's still had this sort of, well, if you're courageous and brave, you don't have to worry about technological gizmos.
In building this new air force, the Nazis possess many advantages that other nations do not, including a first-class aircraft industry, symbolized by the names Messerschmitt, Dornier, Heinkel, Junkers, and Focke-Wulf. Brilliant engineers capable of taking aerodynamics to a whole new level, and a highly educated population that can build aircraft on a mass scale. By 1938, production rises to over 5,000 planes. 1 year later, that figure soars to over 8,000, a testament to the importance Nazis place on the doctrine of air power.
What the Germans were trying to do was to employ new machines, new technologies, but to employ them in the service of a very, very old way of war that had served them well in previous conflicts and they felt would continue to serve them well in the future. I think this sets the Germans somewhat apart from neighboring countries in the 1920s and 1930s in that they are not truly looking ahead as much as they are looking back to their old traditions and grafting new technologies onto them.
Before war is declared in August of 1939, Germany's aerial arsenal is impressive to say the least. Ready to go is the Me-109, a superior single-engine fighter, the Junkers 87 Stuka, a terrifying dive bomber, the Heinkel 111 and the Dornier 17 Flying Pencil, two top-of-the-line medium-range bombers. This, in addition to the largest air transport industry in the entire world, exemplified by the Junkers 52, a workhorse that will be at the centerpiece of the German offensive. Even with all these phenomenal aircraft, a key ingredient is missing, as is often noted by Second World War historians: the absence of strategic bombers. This void does not go unnoticed in 1935, when General Walter Wever, realizing their importance, enthusiastically supports the building of long-range aircraft to battle any potential enemy, most likely the Soviet Union.
General Walter Wever was promoting what he called the Urals bomber. He believed that the industrialization, tanks, planes, etc., that was going on in the Urals area had to be demolished if you were going to win a war against Russia.
Wever writes, "Air power carries the war right into the heart of enemy country from the moment war breaks out. It strikes at the very root of the enemy's fighting power and of the people's will to resist."
Yeah, Walter Wever was very much in favor of this long-distance bomber to try and bomb Russia. And that actual project was given the name of the Ural bomber. Wever actually then put specifications out to both Dornier and Junkers for the building of this long-range bomber. Out of this came the Dornier 19 and the Junkers 89. But neither of these aircraft had the performance that was currently available in the United States on the B-17 Flying Fortress. So therefore, neither of those airplanes really progressed very far beyond a couple of prototypes.
Dying due to a plane crash in 1936, his doctrine epitomized by the Dornier 19 and the Junkers 89 are scrapped by Goering.
Goering, I think, didn't go along with this because he rather took the view that Hitler had, that they could win by blitzkrieg, and they wouldn't be required to get into this lengthy process of using heavy bombers.
Inquiring as to how many twin-engine planes can be made for every four-engine one, the answer given to him is 2.5. The Field Marshal response is that the Führer does not ask me how big my bombers are, but how many there are. It is important to note that the decision not to build long-range bombers cannot be considered a failure. For Germany, the raw materials needed to build such planes would require large amounts of rubber, metals, and fuel, all of which would have to be imported for a hefty price. Of the 4,500 tons of aluminium needed per month for aircraft production, only half is available during the Wefer era. The Air Force that he and others envisioned was simply uneconomic at the time. What truly represented the German way of war is instead a tactical Air Force.
The German War of Movement attempted to defeat as much of the enemy army as possible within the opening weeks of fighting. So the tactical level of fighting for an individual position, and then the operational level of attempting to defeat an enemy army. But arguably, Germany had never been very good, and this would go back to Prussia before it, at the kind of long-term strategic planning that the Allies were so skilled at in World War II. Arguably, this was because the Germans felt they had to win all their wars quickly or they would not win them at all, and that attempting to play strategic warfare with the vast economic and industrial resources of the United States was a losing game from the start.
Working closely with those on the ground, the Luftwaffe is wildly successful as the Second World War begins. Poland is easily demolished. Norway is taken away from the British effortlessly. The Low Countries and even the power of France cannot resist German might during the year 1940. It appears that nothing can stop Nazi forces from gobbling up the continent of Europe.
Certainly the Luftwaffe played an extremely important part in the opening German victories of World War II. And when we say opening victories, we don't mean the first 6 months, we mean the first 2 years, in which it looked like a German victory was very much in the offing. The German Air Force was very skilled at the tactical level, that is, cooperation with the ground forces. It was extremely successful at the operational level of war, the intermediate level, that is, carrying out campaigns against enemy supply lines, for example, feeding troops and men to the front.
With the fall of France, Britain is the only nation standing in the way of this German juggernaut. In order to finish off the rebellious island nation, a plan known as Operation Sea Lion is approved. It calls for the Luftwaffe to achieve air superiority over the English Channel. Once this is completed, German forces will be deployed onto British soil. However, during this pivotal battle, the Luftwaffe is dealt its very first aerial defeat. Primarily through the use of Spitfires and Hurricanes, the English are able to push back German planes from the coast of Britannia. While this monumental struggle ensues, we discover one of the Luftwaffe's greatest failure, its lack of coordination with the Kriegsmarine.
Goering said, everything that flies is mine, and bitterly fought against any attempts by the German Navy to get a hold of a piece of the air action. When they wanted long-range aircraft assigned to them, Goering, actually, Dönitz went behind Goering's back directly to Hitler, and I think got a dozen of the Focke-Wulf Condors assigned to him. Goering, when he found out about this, was furious and actually cut off all cooperation with the Kriegsmarine at this point.
Despite pleas by Admiral Raeder to create a separate air force for the Navy, Goering refuses to give the green light to any potential inter-service rival. The roots for this conflict come from each service's desire to be recognized as the one who brought victory to the fatherland.
Of course, there has always been the rivalry between the Navy and the Air Force from the point of view that we refer to ourselves as the Imperial Navy and refer to the Air Force as the Nazi Air Force. So that differentiated us already in attitude and character.
In hindsight, Goering's decision proves fatal as Germany and Britain battle it out in both the skies and on the high seas. Winston Churchill would write that the greatest threat to Britain was the Battle of the Atlantic, where German U-boat submarines are enormously successful in sinking English shipping.
I think Churchill was quite correct that the Battle of the Atlantic was the one front where Britain could really lose the war because they were so dependent on supplies, even food, coming from North America, that if that lifeline was cut, Britain would have been really in dire straits.
With the defeat of France, bases are built right on their coast, giving these vessels an even bigger theatre to disrupt the lifeline of Britain. Had aerial forces worked closely with these U-boats, or if a separate naval aviation wing was created, it would be a game-changer in Germany's war against Britain. Proof of this can be seen in the Focke-Wulf 200 Condor, an aircraft that, despite its limitations, is excellent in attacking English ships. With no more than a dozen planes, they successfully sink 85 merchant vessels and over 300,000 tons of shipping.
When the Germans started to deploy a fairly small number of the Focke-Wulf 200 Condors to attack Allied shipping, they were able to have really a devastating effect.
Also, had the new invention of a magnetic mine been dropped by Luftwaffe planes into the English Channel, its enemy could have been starved out of the war. This marks the first major failure of the Luftwaffe.
It was our common complaint of us, the little people, let's say, that there was no coordination whatsoever between the German Navy and the German Air Force.
With a stalemate on the Western Front, Germany decides to keep the British at bay and instead focus attention on their ally, the Soviet Union. Enacting a war plan known as Operation Barbarossa, some 3 million Nazi soldiers equipped with rifles, tanks and planes begin the biggest land assault in history. Using less than 3,000 aircraft, a force smaller than that utilized in the battle against France, Germany is miraculously able to push back Soviet forces to the suburbs of Moscow. The decision to launch Operation Barbarossa exposes the Luftwaffe to its second major failure: the lack of maintenance and repair on the ground. When a German aircraft is damaged, it is sent back to the fatherland for repair. When fighting a relatively short and tactical war against France, this particular system works fairly well. When fighting a long, drawn-out war of attrition against the communists, however, it proves to be a gigantic blunder. In the Soviet Union, with the fighting taking place far away from the major cities of Germany, the time it takes engineers to repair a damaged aircraft and have it sent back to the front is enormous. And by 1941, less than 30% of the Luftwaffe's airfields are operational, a fact that is almost inconceivable when taken into account that Germany is fighting a two-front struggle. As Field Marshal Erhard Milch would reflect after the war, the vertical organization in 4 territorial determined Luftflotte commands was grossly inadequate for launching a war well beyond the borders of the Third Reich. The attack of June 22, 1941 would in retrospect be a catastrophic mistake. For those like Goering, men who had never fought on the Eastern Front during the First World War, they would grossly underestimate the Soviet will and the industrial capacity of a regime thought to be so backwards by Hitler. Moving its factories far beyond the Ural Mountains, they are out of range of German bombers. The ghost of General Wefer comes back to haunt the Luftwaffe. After the Japanese attack on Pearl Harbor, Germany declares war against the United States. Before this decision is made, Hitler shrugs off any suggestion of a possible American threat in the form of an arsenal of democracy. In declaring war, Hitler foolishly adds yet another enemy to the Third Reich's list, one with a production capacity that is unparalleled. With 2 oceans separating America from the fighting, its people can go on producing without the threat of bombardment. Britain would have hauled the flag down long ago if it had not been for America's support, one field marshal said. With Germany by this time experiencing severe shortage of aluminium and copper, America is fully stocked of these and other vital raw materials. By 1944, the United States is able to churn out over 96,000 planes per year, one every 5 minutes, more than double that of the Germans. Before this catastrophic decision is made, it is important to note that by 1940, even Britain, with its shipping being torpedoed at an unprecedented rate, is outproducing Germany in aircraft. The British are able to improvise, and as a result produce outstanding planes like the de Havilland Mosquito, an aircraft made from plywood. In contrast, by 1941, with Nazi forces engaged in a two-front war, total production is just over 11,000 planes, a yearly increase of only 3,000 from when the war began. It is clear that the Third Reich's total output is only a fraction of what it could be.
One of the failures of the German Luftwaffe was their inability ever to work out a sane procurement and production process. Prototypes would be built and abandoned. They would be rebuilt and altered by Hitler's order and abandoned, and rebuilt a third time and perhaps put into production as an aircraft very, very different from what the original designers had intended.
This lack of planning and foresight can be attributed to the man who took control of Luftwaffe production in 1936, long before the war began. His name is Ernst Udet. An outstanding ace from the First World War, he is put in control by Goering, replacing Wilhelm Wimmer. His appointment to this powerful position marks the third, and possibly the greatest failure of the Luftwaffe.
Goering placed one of his World War I fighter ace buddies, Ernst Udet, in charge of technical developments. Udet really didn't know anything about this stuff.
Udet's forerunner, Wimmer, has been outstanding in overseeing the Luftwaffe's second-generation aircraft during the pre-war era, including the Me-109, the Junkers 87, and the Heinkel 111. With Udet as his replacement, however, the next line of aircraft is a far cry from their predecessors.
One of his hobby horses was dive bombers. He had seen, actually, in America, interestingly, between the wars, a demonstration of dive bombing, thought every German bomber should be made into a dive bomber, and then even ordered this new four-engine bomber, Heinkel 177, under development, to be made into a dive bomber. Well, Heinkel himself, who was, after all, an engineer who understood this, kept trying to talk him out of it, said this is ridiculous, but was overruled. And so they had to go back and strengthen the wings of the 177 to try to reduce drag so it could actually dive at high speeds. They tried mounting the engines in pairs instead of having four engines like you would normally think you would do on a bomber. They were mounted front and back in a single pod on each wing. This resulted in so much heat being generated that the engines were constantly overheating. So it really, I mean, it was a crazy idea, and it led directly to delays, and I guess you can really say the ultimate failure of Germany to field an effective four-engine bomber during the war.
The Heinkel 177, with its odd tandem engine arrangement and an insane requirement by Udet to dive bomb, makes this plane a complete disaster from start to finish. The aircraft becomes known as the dead racehorse, with only a handful ever getting the chance to fly.
The Heinkel 177 and the Me-210 go hand in hand as one of the Luftwaffe's major disasters.
The Messerschmitt 210, a replacement for the Me-110, is full of problems that are never ratified.
When he came up with his Messerschmitt 210, the RLF said, oh yes, that's very good, let's immediately, we'll order 10,000. Or whatever it was, but they went into mass production and the thing had hardly flown. It was a complete and utter disaster for Messerschmitt, which he never lived down, and they had to convert a lot of the built Me-210s into Me-410s by taking the aeroplanes to pieces again and reassembling them with new parts to turn it into a flyable and operational machine.
As one aircraft representative is overheard saying, everything turns to dust in Udet's hands. Only one aircraft, the Focke-Wulf 190, is considered a success under his watch. A reluctance to make the hard decisions also proves costly, as resources are diverted to projects that are simply unfeasible during wartime. By 1941, the need is for long-range strategic bombers, with America producing the B-17 Flying Fortress and the British reworking the Avro Manchester into the 4-engine Avro Lancaster. Germany, in contrast, falls dramatically behind the Allies in producing 4-engine bombers. Udet, with all his failures, commits suicide in 1941, leaving the Luftwaffe in shambles. With a Soviet victory at Stalingrad, German forces are pushed back, marking the beginning of the end. And as American and British bombers begin destroying German factories and city centers from the sky, the philosophy that General Weber endorsed years ago is coming true. Strategic bombing is proving vital in weakening the German war machine. Under the command of Field Marshal Erhard Milch, production is able to climb to 25,000 planes a year, a respectable increase, but nothing compared to what the Allies are able to produce.
U.S. procurement policies, which become a giant bureaucracy, embodied in the War Department and soon thereafter, World War II, embodied in the Pentagon. The Germans were simply not able to compete on that level.
In 1944, Germany is being outmaneuvered in the realm of aircraft by the rate of over 4 to 1. At this point, there is simply no way to compete with the United States or the Soviet Union. While much is written by historians about Allied coordination in resources and materials, little can be found about Germany's willingness to use its own allies' means of production to their advantage. This is yet another failure of the German Luftwaffe. Without a common goal and being on different sides of the world, the Empire of Japan cannot be considered Germany's biggest ally. Its most powerful friend during the war is instead the Italians. Unfortunately, with their own air force in shambles, the Nazis are reluctant to give them the licenses and the engines to build German planes on Italian soil. This proves to be a pivotal mistake, as Italy could have tripled aircraft production with German assistance, producing possibly 30,000 planes during the war. Also, Italian factories would have been out of bombing range for the Allies during the year 1942 and might have changed the outcome in the Mediterranean. Germany's other allies, Romania, Hungary and Finland, are all capable of making aircraft, but lack the knowledge and resources that the fatherland can provide. Had these nations been granted licenses to build Nazi aircraft on their own soil, there was a good chance that this coalition might have tipped the scale in favor of Germany during its pivotal battle against the Soviets during 1941. The decision not to fully utilize the resources of these nations can be attributed to Germany's desire to be the dominant power. There is widespread resentment against the Italians by top Nazi leaders who see them as merely riding off the coattails of German success.
Our feeling always was, with the experience of the First World War already, we wish the Italians were on the other side.
People like Hermann Goering see these smaller countries as the providers of natural resources, with the fatherland supplying the finished products. This marks another tragic failure of the Luftwaffe. In early 1944, Germany unveils the Messerschmitt 262, a revolutionary jet plane that can hopefully take down the flying fortresses and mosquitoes that are destroying their cities.
Later on, of course, they produced the world's first production model, general use jet aircraft in the form of the Messerschmitt 262, the Me 262. The Me 262 as a pure fighter was an amazing sight to see, and in fact, anyone looking at it today is still struck by the modern and sleek lines.
Now, the Me 262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II.
The Me 262 is years ahead of its time, symbolizing the fatherland's creativity and innovation. In many ways, however, the Me 262 also symbolizes Nazi indecision.
Unfortunately, the Me 262 got caught in a very, very arcane and difficult procurement process within Germany, wherein basic designs were put forward by competent engineers. They were then changed by upper echelons within the Luftwaffe, and of course they had to pass the Hitler test. And no aircraft passed the Hitler test without being significantly modified. The Me 262 is no exception.
After Professor Messerschmitt tells Hitler that the aircraft can carry up to 1,000 kilograms of bombs, Field Marshal Milch, in a fit of rage, tells the Führer that even the smallest infant can see that the 262 is a fighter, not a bomber. After months of wavering, the plane goes ahead as a fighter-bomber, taking the sting out of what could have been a ferocious punch. They may possess this wonder weapon, but have few men that can fly it. This becomes the Luftwaffe's final failure, its pilots' lack of training. During its heyday, Germany's finest were given approximately 250 hours of flight time before being sent out to face their enemy, considerably more than the British. And with the Second World War going exceedingly well during 1940 and 1941, the Luftwaffe arrogantly minimizes its training program, figuring that the war will soon be over. By 1942, as the tide begins turning, German pilots are given less than 200 hours of practice flying, while Allied pilots are given over 300. With the war turning against them, shortcuts are made to churn out every single pilot possible. Despite this augmentation, by 1944 the average training time drops to just under 100 hours. In some cases, just a quarter of what P-51 Mustang and P-47 Thunderbolt pilots were given. With air superiority lost over German soil, it becomes a turkey shoot for American and British aviators as they begin gunning down Me-109s and Focke-Wulf 190s with ease.
At D-Day, in the final planning, the head of Allied Tactical Aviation was asked, well, what are we going to do about the German fighters? He said there aren't going to be any German fighters over the landing beaches. And he was essentially right, because they'd been wiped out by then.
The decision not to build a pilot training infrastructure like its enemies causes the Luftwaffe to run desperately short on experienced men. So by the time planes like the Me-262, the Arado 234 jet bomber, the Me-163, a rocket-powered interceptor, the Dornier 335 Arrow, the fastest piston-engine plane of the Second World War, and all the other revolutionary aircraft that could have been the difference-maker on both fronts, it is a case of too little, too late. The defeat of the Luftwaffe can be attributed to its lack of direction. With the war going in Germany's favor, Hitler, Goering, and Udet were blinded by a false optimism. The tactical war doctrine that they favored initially was being replaced by a long, drawn-out strategic war that they were ill-prepared for. The arrogant nature in which they brushed off the industrial power of the United States and the Soviet Union. The mismanagement of their own country's aircraft industry on a grand scale, and the lack of infrastructure, production, and training during the Second World War's most decisive years would cause the Luftwaffe to write its own epitaph.
The Stuka, a name that brought dread and fear to hundreds of thousands as it ushered in the Second World War. With sirens shrieking, it dived to deliver death and destruction, quickly becoming a potent symbol of blitzkrieg. Although an effective weapon of terror, the Stuka had serious design flaws. The Ju-87 Stuka had its origins in an earlier design by the Junkers Company. The model K-47 was built in 1927 as a civilian aircraft at a time when Germany was prohibited from making military planes. Later, it was converted to a rugged two-seat fighter with a rear gunner able to fire between its twin rudders. Over time, the K-47 developed into a prototype dive bomber. From these tests, the concept for the Stuka was to emerge. However, the Stuka was not Germany's first dive bomber. When the Nazis came to power in 1933, they quickly rearmed the Luftwaffe by transforming the Heinkel 50 and the Henschel 123 into dive bombers. The modifications to the 123 proved to be much more than just a short-term fix. This formidable biplane provided effective close support and dive bombing service across Europe until 1944. The very first Stuka produced was made in secret at the Junkers factory in Sweden. But the Stuka's introduction to service was held up by problems in development. Hermann Pohlmann, Stuka's designer, had also worked on the K-47, and he chose to adopt much of the earlier aircraft's layout, including its twin-rudder tailplane. But the Ju-87's weight and diving requirements were much greater than the K-47. On the 24th of January 1936, the prototype Stuka crashed in a dive when the entire tailplane simply broke off. The crash killed the test pilot and his engineer. The accident left Pohlmann with little choice but to modify the tail. Accurate bombing required diving vertically. The twin fins and rudders were simply too weak to withstand the strong forces during a dive. Pohlmann's solution was to change to a stronger single rudder. But this created another problem. The vertical stabilizer greatly reduced the rear gunner's field of fire. The Junkers 87 double fin layout had failed, and the tail had already gone through one major transition, which in many ways was a step backwards, at least as far as the plane's defense was concerned. Other ideas like a rudder that could slide clear in flight were tested. This at least would have left the rear gunner with an unrestricted field of fire. The final solution came when an innovative rotating rudder was developed. However, this also meant major modifications to the fuselage. The Stuka's shortcomings forced Junkers to go back to the drawing board. This time they proposed a totally new Super Stuka with an advanced fire control system using an optical gun sight and cannons that would keep any fighter at bay. However, all this innovation would require a complete retooling of the factory and disruption of the existing production line.
Well, my feeling is that there were too many innovations involved in this aircraft, and not very effective ones. In fact, one might say there were minuses rather than pluses. To give the rear gunner a better field of fire by dropping the tail was a very small plus, because there really was an ineffective defensive situation anyway in the Stuka. Very small caliber guns with one gunner in the back. To retract the undercarriage was to remove one of the main drag factors in the dive of this aircraft. And this was a very important factor, the fact that the undercarriage did give such drag, because that did stop acceleration in the dive, and that gives you more time for aiming, better accuracy, and altogether you were removing one of the pluses and putting a minus in its place. These things have their pros and their cons, because the Stuka really, even with an open field of fire, was not very defensible. So it's a matter of weighing up pros and cons, and in this case I believe the cons outweighed the pros, frankly.
There were other considerations too. By the end of 1941, the Luftwaffe had a much stronger day fighter than the Bf-109. The new fighter was the Focke-Wulf 190. The 190 was also strong enough to accurately deliver a bomb, at least in a moderate dive. Since the new fighter now shared dive bombing duties, the Stuka had to soldier on in its original form. However, it was also given a new role where it was to excel. After Germany's abortive attack against Russia, the Eastern Front became very much a tank war. With the Henschel 129, the Luftwaffe did have a specialist anti-tank plane, but there were never enough of them. The HS-129 was heavily armored to provide good pilot protection, but the aircraft was underpowered, a factor that endangered its entire mission. so Stuka's support for the anti-tank role was timely. So the Junkers Ju-87 was pressed into service and became a very effective tank buster. Other jobs included transport missions where the venerable Stuka performed the duty of a communications vehicle, taking staff and supplies to the front line. On the return trip, it was often used to ferry wounded soldiers in a gondola set on top of each wing. In the bitter cold of a winter on the Russian front, these converted dive bombers must have been a welcome sight, although their story is little known. Equally unknown is the role that Stukas would have played had Hitler's only aircraft carrier, the Zeppelin, ever put to sea. Experienced Luftwaffe pilots had warned that if Stukas were attacked and forced to ditch in the sea, there would be serious problems. As their fixed undercarriage hit the water, the plane was likely to cartwheel. Juncker's solution was to use explosive bolts to jettison the landing gear, permitting a much safer ditching on water. The Stuka didn't just stay in service until the war ended, it also stayed in production. Over 6,500 were built before the last one was pushed off the production line, probably cobbled together from damaged or spare parts. Despite the large numbers produced, only a handful of Ju-87s have been found. But the terror they created still remains seared in the minds of survivors.
When he's diving steady, you see the pilot, and he was pretty sure that therefore he can see you as well. You see, and you think, oh my God, he finished me off. And he was diving at you. You had a feeling he's bound to get you. You know, and even in the First World War, people, shall we say, fighter pilots just attacking fire machine guns at people and so on. This you can hide. You can hide behind a wall, you can hide behind a ditch, you can hide behind a tree. You can't hide from a bomb, because bomb will destroy the wall. And it's really and truly frightening.
Well, the Messerschmitt 262, in my opinion, was the most formidable fighter of World War. They had the advantage of, when they designed this, of supersonic wind tunnels. That is clearly shown in the fuselage shape of the 262. They were also well aware of the advantages of sweepback in easing your way through the transonic speed area. The aircraft was designed with these things in mind. So it was going to be a jump ahead of its time, so to speak. When I first saw it, I realized that this was a very different looking airplane. But also, at that time, I hadn't fully realized just the impact its engines were going to have, because we, in the early jet stages in Britain, were using engines operating on the centrifugal principle of jet propulsion. The Germans started off in that area as well, but they had a sector that went onto axial flow. And of course, today, every jet engine is axial flow. They were on the right track right away. But having said that they're on the right track, I must divert for a minute, because was it the right track at that time? I worked closely with Frank Whittle, who was invented or developed the jet engine. And I knew he knew all about the axial flow engine. I said to him, Frank, why have we gone centrifugal when the Germans are going axial? And he said, because in the early stages of jet propulsion, I want to give our Air Force an engine that is simple and reliable. Right he was, because in the early stages, the German jet engines, whereas Frank Whittle's centrifugal engine had an overhaul life of 100 hours, you overhauled it, the German axial flow jet engines had a scrap life of 25 hours because they didn't have the strategic metals to withstand the heat stresses at that time. So, temporarily, we were on the right track. But eventually, of course, the axial flow offered advantages in streamlining because for a given power, you had smaller compressor and turbine discs. And also, of course, it had better specific fuel consumption. And altogether, they were on the right track there. But unfortunately, they couldn't go to the ultimate because, as I said, they hadn't the right metals. However, as an airplane, this was something quite electrifying to fly. The cockpit, there was nothing particularly unusual. It wasn't a cluttered cockpit. It was quite simple, and it had the functional things here, and the engine instruments on the right, and generally good view, good canopy view, and being a tricycle, you had a good view ahead. So altogether, they had a lot going for it, apart from this unreliability of the engines. Even when they were in the air, they were very sensitive to throttle movement. Excessive movement, either accelerating or decelerating, could flame out the engines. And it got so bad, in fact, that eventually the way the Germans were operating was to take off at full power, then ease slowly back to climbing power, and never touch the engines thereafter until you were coming into land. They took that risk, and this didn't pay off, I don't think, because, as I say, although it has a scrap life of, theoretically, of 25 hours, but Adolf Galland told me at the end of the war that his unit, flying the 262 JG-44 at the end of the war, was only having an engine life average of 12 and a half hours. So it goes to show what the vulnerability of that was. Firepower on this airplane, huge. 4 30mm cannons. They had forgotten one thing, and we did the same with our initial experimental jet aircraft. They had forgotten how to slow it down. They did not have dive brakes. And this cost them a little because the aircraft was built mainly to deal with the B-17 Flying Fortress bombers. And when you came in on a dive to attack them, your closing speed was huge. And you couldn't open fire because of the inaccuracy of the guns above 600 yards. So let's say you opened fire at 600, you had 2 seconds before you had to break away because your closing speed was so high. If they'd had dive brakes, that could have doubled the closing speed. Now with a closing speed of 2 seconds, you're firing at random. You're not sighting, you're just pressing the button and hoping you're pointing in the right direction. With 4 seconds, you can quickly sight, adjust and fire. So it made a big difference. Now the ME-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II. When you consider that at the end of the war, the top Allied fighter was the Spitfire Mark 14 with a top speed of 446 miles an hour. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance, and it meant the 262 was virtually inviolate. It also handled quite well in the air. It had no nasty characteristics, really, except if you lost an engine on takeoff before you reached safety speed. But apart from that, I was very impressed. It had two shortcomings, but all the early jets did in our country, in America, and in Germany. Firstly, the engines were very sensitive. It was slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, we hadn't thought, or the designers hadn't thought, of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing. You need some drag if you're going to land, and since there was very little drag associated with the 262, you had to do a long, slow approach to landing. And this was an Achilles heel, because the 8th USAF Mustangs realized this, and the few 262s were picked off, was usually in that phase of the operation. Of the three great airplanes I think the Germans produced in the war, I would say the Ju-88, the Focke-Wulf 190, and the Me-262 were the three. The Ju-88, in my opinion, was a first-class medium bomber. The Ju-88 G4, for example, had a top speed of 400 miles an hour, which was 6 miles an hour faster than the 190 A4, its contemporary fighter. So it was a formidable airplane. And also the Germans had learned from the mistakes of the previous medium bomber, the Heinkel 111, where you had the crew separated by the bomb bay. You had the flying crew up to the front and the defensive crew at the back. But there could be a breakdown in communication. And also, there could be a breakdown in morale if you have the two separated. They had learned to put the four crew of the Ju-88 into one glasshouse, I think you would call it, on the fuselage. And crews themselves were very enthusiastic about the airplane. I flew it quite a lot, that and the 188. The 188 had a rather different rudder effect, and I would say it had improved slightly over the Ju-88, but a negligible amount. It still had the good flying characteristics of the 88. In fact, slightly better. And I was very impressed with both types of aircraft. The Focke-Wulf 190, as a fighter, was first class. There is no question of that. It was an outstanding airplane. And inevitably, as the war progressed, there were attempts made to keep up with the hunt, so to speak, and give it a variety of roles. And there were many different marks of 190, and it eventually gravitated into the fighter box. In that role, it was quite effective, actually. Fighter bombers have a limited role. They are used against what I call targets of opportunity. You don't use them to come in and bomb an industrial layout. What you do is you use them to shoot up trains or convoys you see on the road. And from this way, the Focke-Wulf 190 was very effective again. So it was a versatile aircraft. And as it progressed, it eventually had an engine change. The Dora, the later Dora, was a magnificent fighter with an engine change and not really any structural changes other than those to accommodate the engine. But what it meant was, here was an airplane that could keep up with the hunt as the years of the war progressed. So from 1942 right up to the end of the war, the Focke-Wulf 190 was in the top grade of fighter bomber.
Willy Messerschmitt's fabled Bf-109 was manufactured in greater numbers than any other production aircraft. Almost 34,000 were built. Usually referred to as the Me-109, at the time the aircraft was conceived, it was designated the Bf-109. B because the maker was located in Bavaria, and F because the company was called Flugwerk. It was only when Willy Messerschmitt gained full control of the company that the Me prefix was assigned. Throughout the 30s and during the Second World War, Willy Messerschmitt endured a dogged relationship with Erhard Milch, who had gained high position with the fledgling state airline Lufthansa and later with the German Air Ministry, more often known as the RLM. A close friend of Milch was killed piloting a Messerschmitt-designed transport plane, the M-20, on its first flight. Milch was to blame Messerschmitt over the accident, a grudge that was to last for years. Fortunately, Messerschmitt had cultivated a relationship with Hermann Göring, who ultimately became Milch's superior. To get his first Luftwaffe fighter contract, Messerschmitt's Bf-109 had to compete with an advanced Heinkel design, the HE-112.
There's no question the Heinkel aircraft was the better looking aircraft. But, and incidentally, when it came to the test pilots at Rechlin, they gave the 112 the better report, considerably better over the 109. But Udet decided that he was under pressure to produce numbers of aircraft rather than quality. And he realized, quite rightly, that the 109 was far easier to produce in numbers than the 112. Basically because the undercarriage on the 109 was an integral part of the fuselage. So the fuselage and the wings could be produced separately and then joined at a later date.
In the end, the competition was won by the 109 and a legend was born. The 109 first saw service in Spain. Along with other modern German aircraft like the Stuka, the 109 was tested in actual combat conditions. The lessons gained would later be applied to a much larger conflict in the skies over Britain. In Spain, it became clear that the 109 lacked range and endurance. Its slender lines made for greater speed, but left little space for fuel. One possible solution to this problem was to use the Bf-110 to tow the smaller 109 to the combat area, thus preserving its limited fuel for fighting. Novel though the idea was, the towing technique proved impractical for all but glider warfare. However, a few years later, when Germany was suffering from the relentless heavy bombing of the US 8th Air Force, the 109 was employed as a test aircraft in towing a unique glider fighter concept offered by the Blum and Voss company. The BV-40 was a very low-cost fighter glider that would have been coupled to a Bf-109. When the tiny Blum and Voss design was in a position above the American bombers, it was released to attack them, using its two 30mm cannons and their limited stock of ammunition. The BV-40 was so small its pilot had to lie on a mattress in a prone position. However, the BV-40 relied upon its diminutive size to avoid US gunners. Only 7 BV-40s were built before the project was abandoned, probably because the Me-163 was a slightly more practical and self-contained concept. 109s were also pressed into service for clandestine missions, dropping spies and saboteurs behind enemy lines. Special capsules could be attached to both wings, each containing a single parachutist. An often overlooked feature of the 109 was its system of leading-edge slats on the forward surface of the wings. These made for better handling and shorter takeoffs. Interestingly, the concept had been developed and patented by the British Hanley Page Company, and Messerschmitt had to pay for the use of the invention. The slats proved so successful that they were also used in Messerschmitt's 410 and legendary 262 jet fighter. The 262 had another link to the Bf-109, owing to the fact that the jet's nose wheel assembly is actually a single main wheel strut from the Bf-109's narrow gate undercarriage. The 109's narrow gate undercarriage was always a challenge when it came to landing or takeoff, even under normal conditions. At one point in the war, the Kriegsmarine had high hope for its sole aircraft carrier, the Zeppelin. It was always assumed that the Zeppelin would be equipped with Stukas and 109s. The Stuka's wide-gate undercarriage would have been suitable for aircraft carrier landings, but the standard 109 arrangement was not. Accordingly, Messerschmitt set to work to modify the wings so that the wheels could function in a more stable, wide-gate fashion. This aircraft was designated the Me-155. The Zeppelin never put to sea, and the 155 was abandoned, only to be later resurrected by the Blum and Voss company as a very high-altitude fighter concept. But this came too late to help an ailing Germany. Messerschmitt followed the 109 with the Bf-110. Although this later became successful in several other roles, it was never suitable for the long-range bomber escort mission. Messerschmitt quickly offered the 210 as an alternative. But this proved to be a failure, and so the Me-410 was rushed into development. As a precaution, in 1942, the company was ordered to develop a backup aircraft based on existing 109 parts, and using 2 fuselages, which enabled the creation of a totally new aircraft, employing a minimum number of new parts. The Me-109Z Zilling was made as a single-seat, very long-range, heavy fighter. It might have shown great promise if the 2 prototypes had not been badly damaged in an Allied bombing raid. This loss demonstrated that Germany needed a homeland defender more than a bomber escort at this stage of the war. In addition, the Me-262 jet was close to delivery, and this groundbreaking design could have been a real game changer if they had arrived in time. Possible proof of the Me-109Z's viability came with the US North American P-82 twin Mustang. Independently, the German designer of the P-82 chose to follow exactly the same approach as the Me-109Z. 270 twin Mustangs were actually produced and served in Korea and the United States as night fighters. In another pairing, Bf-109s were flown with other aircraft during the Mistral missions. These occurred when Germany's fortunes were declining and the Wehrmacht were looking to develop a new type of flying bomb. The concept would use a disposable unmanned bomber filled with explosives, but guided by a piloted 109. Gliders were first used to prove this concept, but eventually two-engine bombers were employed. The Bf-109 was produced in greater numbers than any aircraft in history. It served the Luftwaffe and other air forces well, and it proved more than an adequate fighter for Germany until it was supplanted by the FW-190. Even then, it remained in active service and production until the end of the war. The Bf-109 was one of aviation's great planes.
Of the three great airplanes I think the Germans produced in the war, I would say the Ju-88, the Focke-Wulf 190 and the Me-262 were the three. The Ju-88, in my opinion, was a first-class medium bomber. The Ju-88 G4, for example, had a top speed of 400 miles an hour, which was 6 miles an hour faster than the 190 A4 at that time, its contemporary fighter. So it was a formidable airplane. And also the Germans had learned from the mistakes of the previous medium bomber, the Heinkel 111, where you had the crew separated by the bomb bay. You had the flying crew up to the front and the defensive crew at the back. But there could be a breakdown in communication. And also, there could be a breakdown in morale if you have the two separated. They had learned to put the four crew of the Ju-88 into one glasshouse, I think you would call it, on the fuselage. And the crews themselves were very enthusiastic about the airplane. I flew it quite a lot, that and the 188. The 188 had a rather different rudder effect, and I would say it had improved slightly over the Ju-88, but a negligible amount. It still had the good flying characteristics of the 88. In fact, slightly better. And I was very impressed with both types of aircraft. The Focke-Wulf 190, as a fighter, was first class. There's no question of that. It was an outstanding airplane. And inevitably, as the war progressed, there were attempts made to keep up with the hunt, so to speak, and give it a variety of roles. And there were many different marks of 190, and it eventually gravitated into the fighter bomber. In that role, it was quite effective, actually. Fighter bombers have a limited role. They are used against what I call targets of opportunity. You don't use them to come in and bomb an industrial layout. What you do is you use them to shoot up trains or convoys you see on the road. And from this way, the Focke-Wulf 190 was very effective again. So it was a versatile aircraft. And as it progressed, it eventually had an engine change. The Dora, the later Dora, was a magnificent fighter with an engine change and not really any structural changes other than those to accommodate the engine. But what it meant was, here was an airplane that could keep up with the hunt as the years of the war progressed. So from 1942 right up to the end of the war, the Focke-Wulf 190 was in the top grade of fighter or fighter bomber. Now the Me-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II. When you consider that at the end of the war, the top Allied fighter was the Spitfire Mark 14 with a top speed of 446 miles an hour. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance, and it meant the 262 was virtually inviolate. It also handled quite well in the air. It had no nasty characteristics really, except if you lost an engine on takeoff before you reached safety speed. But apart from that, I was very impressed. It had two shortcomings, but all the early jets did in our country, in America and in Germany. Firstly, the engines were very sensitive. They were slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, we hadn't thought, or the designers hadn't thought, of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing. You need some drag if you're going to land, and since there was very little drag associated with the 262, you had to do a long, slow approach to landing. And this was an Achilles heel, because the 8th USAF Mustangs realized this, and the few 262s they picked off was usually in that phase of the operation.
From 1933 until the end of the Second World War, German aviation led the world in aerodynamic design and technical innovation. Long before the outbreak of hostilities, German industry produced an armada of technically superior warplanes. When war broke out, the Luftwaffe quickly overwhelmed some of Europe's most vaunted air forces. Classic designs like the Bf-109 fighter and Ju-88 proved to be superior fighting machines, while others like the Blum & Voss Bv-141 became one of aviation's true oddities. Germany's plan for war in Europe called for an air force that was to be used in direct support of its ground forces. The Luftwaffe's task was to sweep the skies clear of enemy fighters, then destroy enemy troops and installations. Key to the Luftwaffe's success were ground attack aircraft like the Henschel 123 and Ju-87 dive bomber. Ordered in 1934, the Henschel 123 proved to be a rugged and reliable aircraft. It would see service well into 1944. Ground attack was only effective when good battlefield observation and reconnaissance could locate enemy targets. That job was given to the Henschel 126. With its excellent low-speed, short-field characteristics, an outstanding all-round view, the HS-126 proved a great success in the early campaigns of 1939 and 1940. The HS-126 would see action on every front, but by 1941, its limited performance was beginning to show, and a new battlefield reconnaissance aircraft was needed. This led to some of the war's most unusual designs. The Blohm & Voss company was one of the first to respond with their BV-141. Designed around the concept of maximum all-round view, the BV-141 was in many ways a problem looking for a solution. The unorthodox design featured an asymmetric layout with the radial engine installed at the front end of a portside tail boom and an extensively glazed crew nacelle mounted to starboard. Unusual and radical in design, the BV-141 performed surprisingly well, but in the end, it was considered too unconventional, and it was cancelled in 1943.
Yes, in my meanderings throughout Germany, just after the capitulation, I was looking for unusual or advanced technology aircraft. And the 141 intrigued me a little, but I had heard that they were at an airfield called Grossenhain, which was quite near Meissen. There was a big reconnaissance unit which had many reconnaissance types of aircraft, and I thought maybe the 141 will appear there. So I flew there, and there was no sign of one, but I asked if I could speak to some of the POWs who were in the cage there, and one of the chaps told me that a 141 had indeed been there, but the last he remembered of it was not too long ago. It had had an engine problem while flying nearby and had landed on an emergency strip east of Grossenhain. So I flew over in that direction looking for this strip. But it wasn't really a strip, I found. It was a small airfield. And it was, by this time I'd moved into the Russian occupation zone. And I decided to land there because I had already found that that stage after the war, the Russians were still very amenable to the Brits because we had come into the early stages of the war to help them. Anyway, when I landed, there wasn't a lot of aircraft there, and there was a Russian commissar and with an interpreter, and I asked if there was a 141 there. He didn't really know things like the aircraft numbers, but he said there were one or two aircraft left, but his people had examined the airfield, taken away what they wanted, and the rest was left for destruction. So I said, could I have a look around, see what it was? He said, well, yes, why not? Because it's all going to be destroyed anyway. And in one hangar, there was indeed a 141. It had regularly had its engines run up by Feldwebel, who was available. And I said to him, was the aircraft flyable? And he declared, oh, yes, it was. I rather suspected his motive, so I wasn't too sure of what he was saying or believing what he was saying, because I think he had hoped I would fly him out of there and out of the Russian zone. But the Russians were obviously not going to play with that. Anyway, I thought I'll take his word for it and have a go at this. And the commissar didn't object. He said, as long as I stayed within sight of the airfield and I'd only have enough fuel to do that, he didn't mind, because it was due for destruction anyway. And so he let me fly that. And I had about 30 to 40 minutes in it to try out this theory that it flew very nicely in a straight line when on an angular bank of 90 degrees. And after about 2 or 3 goes at this at various speeds and heights, I had trouble with the engine. So I had to return to base. And so I formed an impression that it probably did what it said it could do, but its real reason for failing, in my opinion, was it certainly wasn't an aircraft in the same category of handling as the Focke-Wulf 189, which I had already flown and was its competitor.
Another odd-looking aircraft was the Focke-Wulf 189. The completely glazed central nacelle, twin engines and tail booms were considered too radical for conservative Luftwaffe officials. Performance, however, won the day. Known as the Flying Eye, the FW-189 proved supremely versatile, universally popular, and one of the most reliable aircraft ever to see Luftwaffe service. During combat operations, the FW-189 surpassed all expectations. Despite flying low over the battlefield and taking large amounts of damage, it had the ability to absorb punishment and fight another day.
So I think that killed it more than the theory that it gave the gunner a wonderful field of fire by having no starboard half of the tailplane and being asymmetrically offset to give a clear field of fire to the gunner. So that was my experience of it. Not very impressive, but interesting. The Arado 234 was a beautiful looking airplane. Aesthetically, it was very clean and looked dynamic, aerodynamically, very attractive. And the cockpit was unusual. It was a glass cockpit right at the nose, and it reminded me, when I got into it, rather of like being in a helicopter. You were stuck right out in the front there with completely clear vision around you. On the other hand, you were sitting pretty close to the accident if it had to happen too. And my first meeting with the 234 wasn't a very happy event, because this was up at Grove in Denmark, where we found a number of 234s. And I had one prepared for a flight by the German crew, because we obviously didn't have the expertise to deal with it at that stage. And I taxied it out to the end of the runway. I was well aware, of course, that the Jumo 004 engines so fitted to it had a scrap life, total scrap life of 25 hours. So one really needed to know the service history of the engines you were flying. Now, the Germans were very, very adept at destroying documentation, and we could find no service records. However, I taxied out to the end of the runway at Grosvenor and revved up to full power, ready for takeoff, and then just about to release the brakes when the starboard engine exploded and totally disintegrated, taking most of the starboard wing with it. And this, of course, could mean one of two things. Either the crew had sabotaged it, or it was an engine with 24 hours and 50 minutes on it. We never got to the bottom of what caused it, but suffice it to say that I must have flown something like 300 to 400 hours on the Jumo 004 in various aircraft, and never had another problem with it after that. So it did not give me a poor impression of the 234. On the contrary, when I flew it, it was a very nice aircraft to handle, at a very fast turn of speed. It could fly at and cruise at, well, its top speed was 474 miles an hour, which was very high. And of course, it relied on this speed for its survival because it had no guns fitted to it and was purely a reconnaissance bomber as such. But as I say, handled beautifully. It was straight wing, was not swept wing, and made a very good impression.
The Junker's Ju-52, affectionately known by those who flew her as Iron Annie, or Auntie U, or simply Auntie. The tri-motored transport, which also served as a bomber, was to become a legend, not only for her longevity, but also for her flexibility. She was in fact as much a symbol of the Luftwaffe as the Stuka and the 109.
The Ju-52 was like the DC 2 and 3, I would say an iconic aircraft because its reliability, its three-engine aircraft, very, very reliable, and one wonders why they weren't more frequently used in the UK and the USA, three-engine layout, because it was very common in Italy, was used quite widely in Germany, and but you just have rare cases of it in the States, like the tri-motor Ford, but it's a great solution.
The Ju-52 was constructed with the same corrugated material that the Junkers company was to rely upon for over 2 decades, going back almost to the Great War. During this period, aircraft much larger than the 52, such as the Behemoth Junker G38, also used the same cladding. However, as the 30s came to a close, Junker's corrugated hallmark was starting to look a little tired, especially compared with other foreign types like the American DC-2 and DC-3. Nevertheless, Auntie still stayed in service. The Junkers company had in fact designed a replacement for Auntie prior to the start of World War II. Although they still wanted to retain its tri-motor configuration, it was in most other respects a totally new aircraft.
The Ju-252. It was a distinct difference from the very famous Ju-52. It had smooth stressed wings and a very large cargo fuselage capacity. One of the main features about it was it had a wonderful loading ramp, which was operated hydraulically at the back end of the aeroplane. Now, this was a tail-wheel aeroplane, but after landing, the ramp could be operated and would come down and raise the aircraft's tail. And it was absolutely top-notch. And the incredible thing about it was we actually did experiments to see how this thing would react on the airplane in flight. And at the large enemy aircraft exhibition in October of 1945, we flew this aircraft with the ramp fully open, and as a gimmick, we had a chap sitting on one of the lower steps on the ramp obviously with a harness attached, but he was sitting there pretending to smoke a cigarette. Well, it appealed very heavily to the crowds, and it was quite surprising that this aircraft had this tremendous range of central gravity and was very trimmable in that situation.
The Ju-252 had a stablemate, the Ju-352, which was made largely of wood to reduce the use of aluminum. The Ju-352 proved less successful, although they were the first transport types to use a tailgate ramp that provided a flat surface for loading. Between the two models, only 65 examples were actually produced. When Germany was attacked on two fronts in 1944, they went out of production, as the priority was more fighters to defend the fatherland. Another military transport which used a rear ramp also came from the drafting boards of Junkers. The Ju-290 evolved from the four-engine Junkers 90 airliner, which showed great promise as an advanced design just before the war. The Ju-90 airliner, like most other aircraft of the time, was a tail dragger. So when Junkers created a transport version, they employed the same lifting tailgate developed for the earlier 252. For the time, the Ju-290 transport was a large aircraft when it first came into service in August of 1942.
When I flew the Ju-290, I was very impressed with it in the sense that it had a lovely cockpit layout, a very comfortable layout. It was obviously a civil aircraft adapted to a military role, rather like the Focke-Wulf 200. It was almost similarly armed, not quite so heavily armed as the Focke-Wulf 200, but flew very nicely. And I think it would have made a comfortable, with a little adaptation, a comfortable transatlantic piston engine aircraft in the early days. In fact, after the war, of course, the Americans, they had a group, like I had, retrieving aircraft, German aircraft after the war. They were called Watson's Whizzers. And Colonel Watson actually flew the Ju-290 back to America via Bermuda. And he was very impressed with it, as indeed I was too.
It was certainly the largest land-based powered aircraft in the Luftwaffe inventory. The type was 8 foot longer than the airliner version, had more powerful engines, and a very considerable range. It had been claimed, although never proven, that it made direct flights between Germany and Japan. There was also a need for smaller transports, even smaller than Anti-U. This need was filled by the conversion of a medium-sized glider into a powered aircraft. The Gotha 244 became available in 1943, created by the simple addition of 2 small radial engines to a standard production glider. The radials were actually made in occupied France and as such had little impact on German war production. About 130 of the type were made and proved useful in moving small numbers of troops or light vehicles over short distances. Using the same glider to power plane conversion, the massive Messerschmitt 323 was another attempt to maximize the Luftwaffe's airborne assets.
The Gigant, I saw the 4-engine version and the 6-engine version of the Gigant. In fact, I taxied the 6-engine version. It wasn't airworthy, but I taxied it just as a matter of interest. It was a vast airplane, called Reich, of course, and the one I taxied was the the D model, and it had 6 Gnome engines. And the 4-engine one had proved difficult, inadequate number of engines, and still had to have some assisted takeoff, such as JATO, or rocket assistance on takeoff. As pure gliders towed by aircraft like the Heinkel 111Z, they were a failure, in my opinion. You had 3 Heinkel aircraft playing around with this, all the large Z, and all of them, the whole thing was a very dicey operation indeed. But once you got the 6-engine version going, it was practicable, but of course, it was a large, sluggish airplane.
Because of its great size and slow speed, the Me-323 was a sitting duck, and many were destroyed by the Allies. But when escorted by fighters, its ability to carry large loads was much valued by the Wehrmacht, especially in the mayhem that became the Eastern Front. Vogt built another remarkable transport aircraft, a long-range flying boat named the Viking. The BV-222 story is not unlike the Ju-90s. It was originally ordered as a commercial flying boat. However, as the war approached, the Viking evolved into a large military transport, which also performed some patrol duties. 6 powerful engines propelled the Viking. At first, they were fueled with gasoline, but the BV-222 was intended to be refueled at sea by submarines. Since U-boats are driven by diesel, the practical solution was to convert the Viking to diesel engines. Vogt had another prototype flying boat that was even more advanced. The BV-238 was designed to cope with harsher sea conditions than the Viking could handle. Working only with U-boats, it was expected to go on very lengthy missions. It was designed to be almost self-supporting and able to deal with many types of heavy cargo. To assist in loading the 238, it was equipped with a massive forward waterproof door in the bow. This could be employed in a similar manner to landing craft on a beachhead. What you see here is only a service hatch set within the waterproof door. To assist in handling cargo, there were derricks and winches located on the hull, making the BV-238 more like a merchant ship than an aircraft. There was also a tunnel which ran the length of both wings, providing internal access to the 6 engines, even when the flying boat was in the air. Only one BV-238 was completed. It was destroyed by Allied fighters just before the end of the war. The final example of Luftwaffe gigantism came in the form of the Junkers 390, a stretched 290 with a very capacious 110 feet long fuselage. Propelling this enormous aircraft would require 2 more engines than the Ju-290 and a much greater wing, over 160 feet in span. The extra wing length actually required an additional set of wheels on each side to support the craft as it landed. Only 2 Junkers 390s were ever built, but even these required enormous resources both in labor and material. After the war, only one of the Ju-390s was ever accounted for. This led to speculation as to what happened to the other aircraft, as the type had more range than any other German plane. When they already had a proven workhorse in the Ju-52, why did the Third Reich become so preoccupied with limited numbers of large transport aircraft? One possibility was that Germany had not prepared for a long war. The premise of Blitzkrieg was achieving quick victory by lightning attacks. The English Channel stymied blitzkrieg against Britain. With the rapid fall of France, crossing the Channel became the Wehrmacht's primary objective. This could partially be achieved by gliders, which led to large transport planes like the Gigant. Often overlooked, there was one other design that evolved in the fatherland during those turbulent years: the Arado 232, sometimes called the millipede. Just after Germany invaded Poland, the Air Ministry issued a request for a replacement for the Ju-52. It must be equipped with a rear entry ramp and would employ two of the recently developed BMW 801 radial engines. Arado designers quickly came up with a brilliant design that embraced all the latest thinking in transport aircraft. It had a rear loading ramp, but unlike most other medium-sized transports of the time, it used a tricycle undercarriage. This type of wheel arrangement would not usually work in rough terrain. However, Arado engineers solved the problem by placing a row of small rollers under each side of the fuselage. If necessary, the main gear could be adjusted to kneel the plane down. The 232 would then simply crawl over obstacles on its many rollers, which led to its nickname, the millipede.
At the end of World War II, we were, of course, interested in bringing quite a lot of heavy stuff back from Germany, like wind tunnel gear and even airplanes. And we were looking for cargo planes. We used a German aircraft called the Arado 232, known as the millipede because of the large number of bogie wheels that it had as part of its undercarriage layout. And this was a most effective system of operating on grass airfields, which abounded in Germany in the early stages, and where traction was very difficult to find under adverse weather conditions.
The millipede's level loading ramp made it ideal for all types of cargo. But the Arado 232 had a major problem. It came in the form of this plane, the very successful Focke-Wulf 190, known as the Butcher Bird. The 190 used the same BMW 801 radial engines envisioned for the new Arado transport. After the German failure at the Battle of Britain, there was no doubt that the new FW-90 had priority for the BMW engines. The Arado would have to look elsewhere for suitable power plants, but there were none with the same power as the BMW 801. To solve this problem, a 4-engine millipede was proposed with a larger wing. This change led to delays. The end result was that possibly the best military transport of the Second World War was limited to a production run of less than 20 examples, leaving Auntie to soldier on alone. Eventually, almost 5,000 Ju-52s were made. Many continued to fly around the world for a number of years after the war, including some with the RAF. But Auntie was not their only Luftwaffe transport. 2 Arado 232 millipedes were also flown by the Royal Air Force. During the course of World War II, German aircraft designers embraced many unusual concepts. Some worked, but not all. The Blumenvoss P-163, a product of the mind of Richard Vogt, a German aircraft designer who conceived of many weird and wonderful designs during World War II. At a time when the shortage of aluminum was starting to affect aircraft production, The P163 concept offered a way of partially utilizing steel as an alternative, at least in a limited way. Of course, there would be a weight penalty. However, the additional strength of steel might allow the wings to support a crew gondola and each wingtip, thereby allowing much more free space in the main fuselage for engines, weapons, and fuel. Each of the gondolas would have weighed about 1 ton. Vogt predicted that they would actually improve flight performance by reducing both bending in the wings and turbulence from their outer edges. Project 163 was envisioned as a high-speed bomber, fulfilling some of the multiple roles performed by the famous Junkers Ju-88. The Junkers plane was clearly in the fast bomber class. It had a crew of 3 or 4, grouped together to improve morale and enable better communication. However, the aircraft was lightly armed and relied mainly on speed for survival against enemy fighters. In contrast, the design of Blumenvoss's new proposal necessitated having 2 separate crew seating positions, separated by at least 60 feet. The 163 was manned by a crew of 4, with 2 men in each gondola. There would be a single pilot who would have a spectacular view, not disrupted by turning propellers. More significantly, the pilot sat back-to-back with his navigator and part-time gunner, who was in an excellent position to cover the rear and left flank of the aircraft. To balance the architecture, Project 163's other gondola had 2 gunners, one facing aft, the other forward. At least in theory, this high-speed bomber would have been very well protected. Not surprisingly, there were serious concerns about the actual control of such a revolutionary layout. How would a pilot react to being at the very tip of an aircraft rather than the center? To test the impact of this position on the pilot, an early asymmetric Vogt design was modified. An additional gondola was added to the BV-141's port wing and tested. Another major advantage of the wingtip cockpit was that it would leave the 163's main fuselage less cluttered, leaving space for a power plant that consisted of 2 engines coupled together, driving counter-rotating propellers in a center-line thrust. At about the same time that Project 163 was being developed, the center-line thrust approach was also being explored in the south of Germany by the Dornier Company. Their DO-335 Arrow heavy fighter bomber design was also based on the principle of center-line thrust. One engine set in the traditional nose position, and another placed in the center of the fuselage, driving a propeller at the very back of the aircraft. In the United States, another company, Douglas Aircraft, were also engrossed in another center-line thrust project, which was just as revolutionary. The XB-42, or Mixmaster, was designed as a fast, long-range bomber. It employed 2 engines mounted near the middle of the airframe, driving separate propellers grouped together at the rear. The XB-42's layout, like that of the DO-335, resulted in extremely clean flying surfaces that made for increased speed and maneuverability. Both aircraft were finally made, and with testing so advanced, they probably would have gone into production if the war had continued. Meanwhile, back in Germany, the war was not going well, and the benefits of all new aircraft projects were being seriously reappraised. Although it was reasonable to assume that Blumenvoss had a design that would be the equal of the Junkers Ju-88 in speed and range, and it would also have offered considerably more defensive gunnery, there was still caution about the practicality of the crew positions. How would pilots feel about such an unusual design? The acid test would be the adapted 141 asymmetric plane. The standard BV-141 actually worked quite well. The addition of yet another gondola at the very tip of one wing made the aircraft even more bizarre looking, but it served its purpose and apparently proved that the wingtip cockpit arrangement was workable. However, workable just wasn't enough. Project 163 was cancelled before a prototype was built. There would be no armadas of this unusual-looking aircraft flying over enemy targets, and the addition of another gondola at the very tip of one wing did not turn it into a swan. But it served its purpose and apparently proved the wingtip cockpit arrangement was acceptable. Another factor behind the decision to cancel the 163 was its performance. It simply did not offer any major improvement on what was already proven and available. But performance was not Richard Vogt's primary objective in designing the 163. His goal was to find a way of substituting steel for aluminum, which at the time was in short supply. But as the war progressed, not only aluminum, but all materials in Germany were in short supply. But Richard Vogt's revolutionary concept would later be vindicated by the United States Air Force. In 1949, the Northrop F-89 Scorpion was finally selected by Air Defense Command as its mainstay all-weather interceptor. It was to be armed with cannons, but the A, B, and C models displayed structural problems in the wings, and there were some losses. In 1954, the D model entered service. This had a much strengthened wing and a huge pod mounted on both wing tips. Each pod contained 52 Mighty Mouse rockets. The F-89D became the main production version of the Scorpion, and perhaps supported Vogt's theory on wing bending and turbulence. The post-war B-17 clearly demonstrated the benefits of Vogt's wingtip theory.
We had a B-17 there that had a crew position on a right wingtip. The reason they did that was to develop a central gun control. They had this on the B-29, however it wasn't on a wingtip, but that was what the airplane was built for. However, the war was over and everybody forgot about that, except the Aeromed people thought, oh, what a wonderful thing to find out what it is like to roll an airplane if you're not on the roll axis. Everybody said it didn't really make any difference, but they insisted on doing it, and they built a cockpit in that position out there using the formation stick, which was worked through the autopilot, and you could fly the airplane from this position out on the wingtip. So I got to fly it. The one thing you did learn was, you know, when you're in turbulent air, you keep seeing the wings flap up and down. That's not exactly what's happening. The wings tips are more or less steady. It's the fuselage that's moving up and down. And you could sit out there on that wingtip and jiggle the formation stick longitudinally and make the people in the airplane sick, and you were hardly moving. But you didn't do it too much because they'd get mad at you and get even with you later.
In recognition of his genius, Richard Vogt was invited immediately after the war to work in America. He contributed to many designs, including the ambitious Tiptoe project and its many variants.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.